The subsidiary LLP Institute of Ionosphere. Institute of Ionosphere has its origin in the Alma-Ata Ionospheric Station at the Ministry of Communications of the Kazakh SSR, established in 1943. Sector of the ionosphere, which is composed of three complex magnetic ionospheric stations: Alma-Atinskaya, Karagandinskaya, and Novo-Gazelinskaya, was created in 1961 at the Physico-Mathematical Department of the Academy of Sciences of the Kazakh SSR, with the support of academician KAZAKHSTAN. In 1983, the Institute of Ionosphere of the Academy of Sciences of Kazakh SSR was formed on the basis of sector. The institute is part of the joint stock company National Center of Space Research and Technology of National Space Agency of the Republic of Kazakhstan, KazKosmos. The main challenges facing the institution: the first, creation of Kazakhstan multi-level system for monitoring and forecasting of space weather, which includes monitoring and diagnostics of the near-Earth space by terrestrial and satellite means, development of methods for estimation and forecasting of space weather for taking preventative measures against failure of the satellite and ground-based technological systems, theoretical and experimental methods of analysis and identification of the wave structure of the atmosphere, studies on the relationship of dynamic processes in the atmosphere with dynamic processes in the world, studies of the structure of the ionosphere affecting the operation of satellite navigation systems. The second, creating a system of space-ground geodynamic and geophysical monitoring of Earth crust on the territory of Kazakhstan and prediction of mineral deposits, which includes development of the system of space-ground monitoring of geodynamic and geophysical processes in the Earth's crust and atmosphere, study of the dynamics and mechanisms of evolution of the stress-strain state of the Earth's crust on the basis of building of the geomechanical models of high-light earthquake zones of the North Tian Shan region, creation of complex system for the prediction of technogenetic catastrophes associated with changes in stress-strain state of the geological environment in areas with intensive mining of mineral resources in the North Caspian region, creation of specialized maps of reliable assessment and prediction of the state of natural and economic systems, industrial agglomerations, urbanized areas of Astana and Almaty using data from satellite geodesy, remote sensing of the Earth, other geophysical methods, forecasting and assessment of seismic hazard. The third, development of research and experimental scientific and technological basis of geophysical and geodynamic research responding to modern international standards. Structure of the Institute of Ionosphere, Department of Solar Terrestrial Physics, comprising Laboratory of Physics of Ionosphere, Laboratory of the Physics of Geospace Ties, Laboratory Diagnosis and Prognosis of Space Weather, Department of Space Ground, Geodynamic and Geophysical Monitoring of comprising Geodynamics Laboratory, Laboratory of Studies of Deformation Processes, Laboratory of Mathematical Modeling of Lithosphere, Ionosphere Processes, Department of Expedition, providing carrying out fieldworks on land space, geodynamic and geophysical monitoring in Kazakhstan. Institute of Ionosphere has a modern experimental base, providing the ability to monitor the processes and phenomena in the near-Earth space, inaccessible to observatories in Europe and the US. Orbita radio polygon, located at an altitude of 2,740 meters above sea level, comprising 12-meter antenna TNA 57, which is used for registration of solar radio emissions at frequencies of 1 and 3 GHz. Satellite receivers and apparatus for registration of light intensity and temperature of molecular oxygen and hydroxyl near the mesopause. Orbita radio polygon is included in the International Network of Spectrographic Observations of the Sun, Callisto, organized by the Institute of Astronomy of Zurich, Switzerland, including 24 points from 171 countries of the 5 continents, allowing around-the-clock to register solar radio burst and predict geo-effectiveness of solar activity. Cosmic Ray Station, located at an altitude of 3,340 meters above sea level, which is one of the key in the global network of stations for detecting cosmic rays. Station equipment includes Neutron Supermonitor 18HM64 with a modern system of registration and transfer of data in real time. Belongs to the European base of neutron monitors, NMDB. Complex of detectors, recording neutrons of thermal energies and apparatus for detection of gamma quanta. Experimental data of High Mountain Neutron Monitor are sent into the world's data centers, located in Nagoya, Japan, Boulder, USA, and Moscow, Russia. Alma-Ata Geomagnetic Observatory, the only one in Central Asia, part of the international network Intermagnet, with its headquarters in Edinburgh, England. Data on the geomagnetic field are exhibited on the site Intermagnet. The data of Alma-Ata Observatory were used to create the World Geomagnetic Field Model WMM 2010. Alma-Ata Geomagnetic Observatory from 2010 is part of an international network of stations to normalize DST index, DCX index server. Ionospheric Observatory is equipped with 2 modern ionozonde. Near Almaty, the local network of continuous GNSS observations, global navigation satellite systems, consisting of 10 permanent differential base stations located at Almaty Prognostic Landfill of Seismological Expert Expedition of close scientific cooperation were identified features in the stress-strain state of individual crustal blocks of Almaty region and identify the connection between the processes of deformation and structural features of the Earth's crust. Indicated unique experimental complex allows to carry out in real-time diagnosis and forecasting of the state near Earth space based on measuring the intensity of cosmic rays, geomagnetic field intensity, solar radio flux, and electron density of the ionosphere. The unique 50-year integrated bank of heliogeophysical experimental data, cosmic rays recorded at altitudes of 3,400, 1,700, and 800 meters above sea level, solar radio emission, geomagnetic field, electron content in the ionosphere has been gained at the Institute. His data are regularly updated. The first Kazakh space program of experiments conducted at the station Mir and ISS by Kazakhstan cosmonauts Tokhtar Albakirov and Talgat Musabayev was formed in the early years of independence of Kazakhstan on the instruction of N.A. Nazarbayev, president of the country, under the leadership of Umirzak Sultangazin, the president of the Academy of Sciences of the Kazakh SSR, and direct participation of Viktor Drobzhev, the director of the Institute of Ionosphere. The scientists of the Institute received a number of fundamental results and have been recognized by the world scientific community. The concept of the wave nature of the dynamic processes of the mid-latitude ionosphere was developed. Complete system of ideas about the phenomenon of wave disturbances, their origin, means of control, methods of processing, and interpretation of results was first obtained. A number of unique large-scale experiments was conducted. For example, the project MASA is well known in the country and abroad. 15 research organizations of the Soviet Union participated in its implementation. Conducting experiments allowed to prove the effectiveness of the impact on the near-Earth space of seismic events, explosions, explore the penetration of gravity and acoustic waves to the heights of the ionosphere, to detect the existence of atmospheric-ionospheric links of non-acoustic nature, transformation of acoustic waves from the Earth's into electromagnetic disturbances of various types. Institute of Ionosphere was the founder of the theory and a new direction in space physics, the study of transient processes in near-Earth space and the solar terminator. Theoretical calculations were experimentally confirmed by the study of spacetime, seasonal, daily features of wave generation by the solar terminator for different latitudes, including the height of the magnetosphere. Regional model of ionosphere for Kazakhstan, correctable by an ionospheric index of solar activity, has been developed, allowing in particular giving the forecast of radio wave propagation conditions by various interested government agencies. Theoretical group model of developed turbulence has been built that provides basis for the establishment of packages of numerical programs, calculation of practically important turbulent phenomena associated with the processes of mixing, spraying, turbulent flow around bodies, etc. The results of these studies received wide practical application for the improvement of quality indicators of radio communications, navigation, and direction finding, in the development of new radio and geophysical methods to detect nuclear explosions, start of spacecrafts, and earthquake prediction. In particular, the new method of ionospheric detection, identification, and assessment of the capacity of the underground nuclear explosions was developed at the Institute. The results on the effect of launch vehicles launches from Baikonur Cosmodrome in near-Earth space were obtained. Extended system allows to record and analyze real-time increase in the radiation environment in space that cannot be shown on terrestrial stations of cosmic rays middle latitudes. In 2001, the Department of Spaceground, Geodynamic and Geophysical Monitoring became a member of the Institute of Ionosphere, which greatly expanded the research areas. Within the framework of applied research in the field of space activities, based on space-ground complex of monitoring geodynamic environment, based on application of GPS technology, interferometric methods of remote Earth sensing, as well as using mathematical modeling of geomechanical processes in the crust at the modern level, are carried out in the following work. Geodynamic monitoring and determination of the stress-strain state of the Earth's crust in the most seismically active regions of the northern Tian Shan and Jitsu Alatau. Development of scientifically grounded technologies of terrestrial and space monitoring observations on the development of geodynamic processes on the territory of the Caspian region and the prediction of hydrocarbon deposits needed to control emergency situations at the oil and gas industry. For example, such as accidental releases of oil and gas in the fields of the main and infield pipelines, oil spills in the offshore Caspian Sea. The results of these studies allow to carry out zoning in the Caspian region of Kazakhstan and highlight areas of energy saturation and decompression of Earth's crust, which are the criteria of seismogenic and oil prospects. Approach the choice of a place of drilling exploratory wells by purposefully and selectively. Development of mathematical modeling and satellite studies of the stress-strain state of the soil structure system is also made for industrial agglomerations and cities with high-rise buildings, which may be taken as the basis for monitoring of especially responsible business structures of long objects, such as irrigation systems and hydraulic facilities. Under this theme, working on defining the movements of the Earth's surface for Almaty and Astana are conducted. Recommendations for seismic resistance based on the number of floors of the newly constructed buildings, type, and parameters of foundation are presented on the basis of global and local network of GPS stations. Thus, the priority research directions of the Institute of Ionosphere. Terrestrial space geodynamic and geophysical monitoring the Earth crust of Kazakhstan. Solar terrestrial physics and space weather forecast. The results of research of scientists of the Institute for each of these areas, based on the data received by the international scientific community, showed a close relationship between these directions. It was found that the characteristics of near-Earth space, ionosphere, magnetosphere, Earth's radiation belt, responding to the activation of geodynamic processes in the lithosphere, and accordingly, geodynamic processes in the Earth's crust are correlated with the activation of the processes on the Sun and in near-Earth space. Institute of Ionosphere, having a unique experimental base and highly skilled scientific and engineering staff, being at the crossroads of fundamental and applied science, is aimed to address the serious scientific and practical problems in the field of solar terrestrial physics and geodynamics.